Hi everyone, and welcome to the following of Index.js of the blockchain tutorials. In this part we're going to continue with the interaction of our smart contracts, which was simple_token.sol. So here, as you can remember, we transferred some tokens from one of our accounts to the other, and now we're gonna get the balance of both of the accounts to check whether this has been done successfully. So in order to do so, we're also going to write another function. So this is another async function, and it's nearly the same as what we've written for the above function, which is transfer of token. So this one is called getBalance, and it will get the same variables, but it will get one address. So it will get JSON file path like this, and address here. Also it will get the Web3, so Web3 object. And now let's initiate the function. Now most of the lines are the same, so we will get the ABI from our JSON file. So let me copy and paste it here and not waste our time writing it. Also we need the deployed data JSON file, so we'll get this from here. But notice that we do not need to estimate the gas fee here. We just need to create the contract data here from the ABI and contract address, and then it will be good to go. So now let me go ahead here and paste the lines. Here we go. And what we're gonna do next is write const contract. So we've got the contract, so we need to write const balance, and this one should equal to await deploy tx, or actually contract itself. So contract dot methods dot balances. So you might wonder what this one is, and also here we've got the transfer, so you might wonder what this is. So let's take a look at our smart contract and see. As you can see, we've got the transfer function here, and it gets two variables, 2 and the value. So this is the token amount, and this is the address to which we're going to transfer the tokens. So if we get back here to our Web3 function, this is going to get the method from the smart contract. So the method is transfer, and this is the to address, this is the token amount. So as you can remember, here we have the value. For the transfer we have the value, and we have the to address, right? This is exactly the same here. For the balances, we will have the balances, which is a mapping instead of our smart contract. As you can see here, let me show you the mapping. This is the balances mapping, so we're going to do the same, get balances here and call it here. So here we would send the transaction for this one. We would send it because this is a function. This is sending the transaction, but this is a mapping, so we will need to call this. And so the balance, each balance mapping has an address, so we need to check the address, which is this one, right? So we'll need to write the balance instead of the parentheses. So it will simply get the address, and then we will use dot call instead of dot send, because this one we're just going to call in order to see what the value is. And now in the end we will console.log the value, console.log. So this one is very much simpler than compared to the previous one. So here we can say here we can use the backticks. So balance of, so we'll have $, brackets open and close, and address, balance of this address. So we'll have colon, and then we'll have again another $, and brackets open, and we'll have, oh, and by the way, let's put the backtick ending here. So this one will be the balance that we've defined here. So right now we can, that's it for our function. We can get the balance like this. Notice that we want to get the balance for two addresses, the address that sends the tokens and the address that receives the tokens before and after the transferring of the tokens. So in order to do so, let's get into the execute sequentially. And so we're gonna run this function twice, before the transaction and after the transaction, or the transaction, I mean transfer of the tokens. So here is transfer of the tokens. Some other place it's another transaction, but it's generally a transaction. So after the deployment of the smart contract, we will use this get balance here. And notice that here we want to get the address 1 and address 2. So let me copy and paste it a number of times. So that's it. And here we will also add await here again, because it takes time. Sometimes when you're on the testnet or mainnet, it might take 1 or 2 seconds, but here it will be just a fraction of a second because it's a local network. So, so notice that transfer of the tokens when you are on the testnet or mainnet might take some seconds. So we'll have this, we'll need this delay bit after the transaction. So what we want to do is to create a promise and create a set timeout for 5 seconds. So wait, and we'll have new promise, and then we'll have resolve. So the result is like this. We set timeout like this, and for the resolve we will have 5,000 milliseconds, which is 5 seconds. So here we go, and then we'll get the balances of the, so this is address 1, address 2, so we'll get the balance of the two addresses, and we'll also get the balances of the two addresses after the transferring of the tokens, right? So before that, the address 1 should have 21 million tokens, just as we minted at the time of deployment. We said that the number of tokens should be 21 million, and then after the transfer of the tokens, which we defined 10 tokens, determined 10 tokens to be transferred, then we will have the balance of this one, which is 21 million minus 1, and this one should be 10 minus 10, and this one should be 10, right? The address 2. So now we'll save the index.js and run this code once again. So there seems to be a problem whenever you see something like this. There is an error, so contract is not defined, and this should refer to this function, right? So contract, this should be something like deployed contract, right? Yes, that's exactly it, and that refers to this one. So it's deployed. This is deployed contract. Let's save this, rerun the code, and as you can see, the same thing happened here. As you can see, the balance of this one is 21 million, this is 0, and after 5 seconds we will see that this is 20 million and 999 99 actually 990 tokens, right? It's a bit hard to read, and this is 10 tokens, right? So 10 tokens from this account has been transferred to the other account, and this is the transaction receipt for sending the tokens. So that's it. We've managed to transfer tokens from this account to the other, and notice that it takes here on the local net, it takes just a very small time for this to happen. But once you are in a test net or mainnet, and depending on the internet speed and also the difficulty of the network, it might take some time for the transaction to happen. That's why we just set a timeout here to control the amount of time that takes for this transaction to happen, and then get the balances once again. So if you don't set this timeout, then you will sometimes see that the balances will not change, and you might think that no tokens have been transferred, while it might take some time for that process to happen. So it is most of the time recommended that you have this set timeout in order to control this process. So let's try this process with another number of tokens, right? So let's do this with 100 or maybe 2000 tokens. So let's save this and rerun the code. And after 5 seconds, you will be able to see the difference. As you can see, the difference has been made. So 2000 tokens has been transferred from this account, which is the first one, to the other. And this is the transaction receipt, and these are the data. So let's head over to Ganache and take a look at the transactions here. So we've got a couple of transactions. So this is the contract creation, and this is the contract call. You can take a look at them. Also 7 blocks have been mined here, as you can see. So you can take a look at some of the information about the transaction. So we have a contract call. Also here, notice that we have events. So for the kinds of smart contracts that we've defined the events, we'll see the events coming here. But right now we have no events for these transactions, so there's nothing happening here. Also, you can take a look at the blocks. You can take a look at the times that those blocks has happened. So this is not really important on Ganache, but once you take a look at this on Etherscan for testnet or mainnet, you will be able to see a lot of differences. So up to now, we've learned how to work with local nets in using Ganache. So we'll also be working with the Ganache CLI, which is a much easier tool to work with. You don't have to open the Ganache UI every time. You will just open the Ganache on one of your bashes here and make it up and running. And once that is up and running, you can work with the local net just from your terminal without ever using to work with the UI. Also notice that we will then work with the testnet, and so that is the time we're ready to work with the mainnet, but we don't cover that part because it will cost us gas fees. But here with testnet, it will cost us nothing. So testnet is just the same as mainnet. That will suffice. And then we'll go after Truffle, Hard Hat, and then Python Brownie. So I hope you've enjoyed this tutorial. And until the next one, goodbye.